Carpe Diem VPN. Seize the network.
Hey everyone, it's Tim with Carpe Diem VPN here, and today we're going to be adding some new stuff to the lab. In my last video I covered how we're going to be adding a new transport color and a third branch in which we're going to run BGP, but right now we're just going to focus on the transport color. Since we're adding MPLS, we're going to need to add a new feature template for the interfaces that will be connecting to that new transport color. So let's do that now. So we'll come over to the vManage and we'll go into our template configuration. And we'll need to create a feature template. So we'll go to Add Template. Here we have to pick what devices we're using. Now in this lab, we're only using CSR 1000Vs, so that's what we'll tag here. If we're using vEdge Cloud or some other kind of virtual device, we would need to pick that as well. And then we'd have to deal with the overlapping templates and make sure that whatever we're picking is a shared template between both objects. But in this case, we're just using CSR 1000V. Now, what do we need here? What we're going to need is the Cisco VPN interface Ethernet. And you can see that it's tagged for, we could use it for management, WAN, or LAN. So it's kind of a catch-all interface config. Okay. Once the template loads, we first have to give it a name. So here we're just going to say VPN 0, which is our underlay VPN. And we'll just say MPLS and template. Now, for some reason, the description is required. I'm not sure why that choice was made, but we have to put some kind of a description here for it to be a valid template. So we'll just say VS color template. Now I have to go through and pick all the specifics for this color, this interface. Notice that by default, and when I say by default, I'm talking about this blue check mark here. A blue check mark indicates that we have some setting by default that you can change. By default, the interface starts in a shutdown state. There might be good reasons for that, but in our case, once we attach it to a device template and we push it to a device, we actually want to turn it up. So we're going to change that. And you can see we have a couple of other options. Global means for every device that uses this feature template, the setting will be the same. And device specific gives us the opportunity to set a variable, meaning for each device that uses this template, we can enter a different value or toggle something differently. So in this case, we want every device to have this turned on. So we're just going to say for every device, it's not going to be shut down. Now the interface name is going to be different per site or per device, depending on how things are set up. So we're going to make that a device-specific name. And it's very useful to give it kind of a friendly name or something that you're going to use to know what this is. So for something like this, I would usually do something like MPLS is interface. Okay. So we'll see later on once we start attaching this to a device what that looks like. But yeah, for now we'll just use this. Now here for the IP address, of course, this depends on whether or not you're getting the IP address dynamically or static. Now we're going to get ours statically. So I'm going to go to device specific again, because of course each device that uses this template needs to have a different IP address. And I will say something like MPLS IP address, something like that. All right. And then of course, based on whether or not we're using other features, we could check or uncheck some of this. By default, a lot of this is turned off or just kind of inherits the defaults. Let's see. So is this a tunnel interface? So a tunnel interface is a WAN interface. It's an interface on which we expect to be encapsulating and building IPsec tunnels. So because this is going to be our WAN interface for MPLS, the answer is yes. So we're going to turn that on. And you notice when we turn it on, if I can get it to turn on, there we go. So now that it is a WAN interface, there's a lot more settings that we need to check here. So there's some feature templates, like for example, we can turn on per tunnel QoS, it's off by default. So here's what we need to change. So notice that color is default. That's a valid color. That's a default color. We are going to change it globally to an MPLS color. You see we have lots of options. I'm going to change it to the MPLS color. And again, the color is just a tag, although it does have significance. The MPLS and private colors have significance versus the public or biz internet type of colors. It has to do with whether or not we expect to build tunnels over a NATed address or a pre-NAT address. And we can talk about that a little bit later. Although we kind of covered it in some of the Vbond stuff we talked about. It depends on that. Restrict is a keyword that says, I will only build tunnels to other TLOCs and other devices that are using this color. So for MPLS, we might want to turn that on. I'm not going to turn it on right now because I need to check the underlay. I don't remember if I had the MPLS having connectivity through the internet or not. But this is something, restrict is something you would turn on specifically if you only wanted to build tunnels with other colors or other devices that had the same color. Let's see. So control connections has to do with whether or not we expect to be able to build connections to the infrastructure, the vSmarts and Vbond and vManage over this color. So with MPLS, there may not be a reachability to these devices if they live in the internet, as an example. Again, this depends on whether or not you have MPLS reachability to the internet. So I'm going to leave it on, but this would be something you would turn off if you didn't need or couldn't provide connections over this color to the internet-based controllers. Maximum controlled connections is just what it sounds, which is to say that we can decide how many total connections we'll allow to be built. In previous versions of the Viptela code, I think we actually needed to set this to control connections on, but maximum connection 0. I don't know if that's changed. I might actually experiment with that a little bit when I work on the lab a little bit later. But that's basically both do the same things. If we say control connection on, but maximum control connection 0, it's exactly the same as if we had said control connection off. All right, Vbond is stun server. There's a lot of baggage with this. This has to do, Vbond already kind of acts like a stun server because it learns the pre-NAT and post-NAT address of the WAN edges. So the Vbond stun server turns on some extra functionality there. It's in the documentation. I'm not going to cover it here. We use port hop when we have multiple WAN edges behind a single NAT, and we're dealing with like a PAT or a NAT overload type of setup. By default, the WAN edges try to connect to the Vbond, and then of course all the infrastructure, on a specific port. It's 1, 2, 3, 4, 6, and if it fails, it will increment. And so what port hop does is tell it, okay, well, we're not restricted. Like there's not a firewall restricting specifically which ports we can use. So it's okay if you can't make that connection to the infrastructure on the specific port. It's okay to try to increment. So it'll try to increment by 2 the ports that it uses. And the idea is that if there's multiple WAN edges behind a single NAT using a PAT, that they'll basically just figure it out, right? They'll send connections to the infrastructure until something works. All right, so our allow service is kind of our hardening stuff. There are good use cases to turn on some of these services, but you can see by default, we're allowing only DHCP, DNS, and ICMP, and then of course HTTPS. Now we allow DHCP and DNS for like ZTP type setup where we would get the IP address and then allow DNS resolutions. ICMP is just for troubleshooting, so this device will actually respond. We can turn any of these off. And then of course HTTPS is so that we can build control connections. Now NAT, it's just saying, okay, this is a transport interface. Do we have a use case to turn NAT on do like an IP NAT outside type of setup? This would be for something you would turn on if you are going to use this color for direct internet access. Okay, VRRP. So do we have on this interface, do we have a need to run VRRP? This is something you'd probably see on the service side, not on the transport side, but this would be giving your redundant layer 3 gateway. And then of course we have some options to add, ACLs and do QoS type setup on the interface. Again, you would see that more on the service side probably than the transport side, but it does support it. Again, this specific template is shared between WAN, LAN, and management. So we're going to see some settings that may not be applicable to one side or the other. We have the opportunity here to set static ARP addresses. We can see that we can turn on SGT propagation. If we're receiving SGTs downstream, we can turn it on. It will allow us to carry it across the fabric. And then, of course, we have all of our advanced options here. So I'll just call out just a couple here. So these are all pretty obvious and pretty simple. So TLOC extension is something we would turn on if we plan to use this interface to extend a TLOC to another device. I'll cover TLOC extension more later, but it's again, I think I mentioned it a little bit in the last video when I was covering the lab, talking about how a TLOC extension allows us to extend a color or a TLOC from one device to another device. Okay, and that is it. So from a settings perspective, I believe that's all the settings I need to make. I'll just go back and review real quick, make sure that I have no other settings I need to make on this particular interface. Again, we're just turning on the MPLS color, so it's not shut down. The interface is a variable. The IP address is a variable. We've turned on color MPLS, and we're doing very basic color setup here for this lab, and that's it. So we'll go ahead and save it here. And later we'll attach this to a device template. Okay, well that's it for this specific setup for this template. I'll do some more templates as we keep setting up the lab, and I'll create videos for those as well. Thanks for watching.